Everyone, let's see today's problem, which is top k frequent elements. This problem was recently asked to me in an interview for a very good company, you can say. So let's see what problem states. The problem states that we are given an integer array of nums and an integer k and return the k most frequent elements. You may return the answer in any order. So what the problem said as, like, we will be given an array nums, and in that nums the integer may repeat many times, but what we have to do, we have to return the most frequent element. So what will be the most frequent element? For example, in this, if we say 1 1, we have 3 times, then 2, then 3, then most frequent element will be 1, right? So what the problem state that, like, we have to return k most frequent elements. So what the k most frequent element means, like, 1 has been coming 3 times, then 2 has been coming 2 times, then 3 only 1 time, then we have to return the top k elements, right? So top k elements will be 1 and 2, because 1 comes 3 times and 2 comes 2 times. Similarly, if we see this problem, what we are seeing, like, we have an array of 1 2s and 3s. We have to return k equals to 2, means, like, we have to return the top most frequent elements from the array. We can clearly see that 1 and 2 appearing the most number of times. So what we have to do is, basically, we have to, you know keep a lookup for each element initially. Like, how we can check that, like, what the elements we have in that array with the frequency wise. So the basic approach we can look into this is, like, using an hash map. Obviously we have to use an hash map, because we have to keep the count of element against the frequency. And now what we have to see, basically, the basic approach will be using the hash map and sorting. So what we can do for the basic approach is store the elements in a hash map against the frequencies, and basically we'll sort the array of vectors. Like, for that vector we can store, like, pair in that, while iterating through it. So the pair will be in the form, like, basically 1, then its frequency 3. And what we can do is, like, we can sort those arrays based on those two elements. Like, the on the basis of frequency we can devise an algorithm, or we can just sort them and return that. So in that case we will be, like, having a complexity of, you can say, big O of, if we have, suppose, m unique elements, then big O of m log m, where, like, m will be the unique elements, and will be picking the top k elements. So and 1 is for, like, iterating for all the elements of n. So that overall term complexity will be around O n plus m log n. And the most efficient approach, or the approach, like, I gave during my interview, was, like, basically, we can store it into a map. So what I can take is here, unordered map of type int, where we can store, like, the element and its frequency. And what we can do is, basically, just iterate into it the array. Hopefully you know this, how we are iterating this is a for each loop, you can say. So what we can do, for each element we can increment its count. As soon as we find the element, we will increment this count. If the element is not in the array, it will add it and then update it count. Okay. So what we can do is, like, for the optimal approach, we can have a priority queue. So priority queue implementation of, like, min heap. So basically we'll be using a min heap here. So what does min heap will do? Min heap will return a minimum element each time we pop the element from it. So you will say, like, we were requiring k most frequent element, how getting implementing the min heap will result into the final answer, right? So what we can do is, we can create a min heap of size k, and for those k elements, what we can do is, every time once we get the count for each element, we can do is, basically, insert the element based on their frequency first. Like, suppose for 1 we have 3, then 2 we have as count 2, then for 3 we have as count 1. So what we can do is, based on their frequency, we can store those elements in that. So in the priority queue, And the priority queue, since we are creating it of size k, because we are needing at most k frequent elements that are present in that array. So what we will do is, as soon as we get an element which we enter into the priority queue, and the priority queue size increases from k, because we need only k elements, we will pop that element. So you will say like, what will that popping element will do? So the popping will element will do like, it's a min heap, so it will return the minimum element from those. Suppose I have k equals to 2 and we got 3 into inserted into that element, like in the priority queue. And then if we pop the element, then it will only remove this element, since it will remove the minimum element with minimum frequency. So the remaining elements will be with the higher frequency, which we can eventually print it. So how we can do is, we can have a priority queue here, and in priority queue we can have a pair, since we are having two values, one is the frequency and one is the element itself. And then we have to tell it like on which data structure it is going to be stored internally in the heap. We'll be using like a vector of, sorry, it will be a pair. So once we have a pair vector here, then we have to tell it greater pair of type int, and then we will close this as pq. So if you do not provide greater pair int here, it will be a max heap by default. So to tell like it is a min heap, we have to pass this argument as well. So now what we can do is just basically iterate over the map, and in the map what we can do is pq dot push, and we have to push it like as a pair. So what we can do is map dot second comma map dot first. Second, why? Because we want the frequency first. We will be sorting or inserting into the priority queue based on the frequency, not the element itself. Otherwise, how will we know which element has which frequencies, right? So now we will check if we have pushed it, and if by chance the size becomes greater than k, then what we have to do is pq dot pop. As soon as the size become greater than k, we will do pq dot pop, means priority queue pop. So it will remove the least frequent element from the priority queue, and at last what we will be left with the elements which are top k most frequents, and we can simply print it. We'll have a result since it needs a vector of int. Now we can iterate into this. We'll go to maximum of k, since that's the maximum answer we'll be getting. And what we can do is result dot, we can push back our pq dot top, the top element, and the second part, because the first part contains the frequency of it. And at last we will do pq dot pop, and this is how we will get the element stored into it. And what we can do is just basically return the answer here. So return the result, sorry. If we try to run this, so yes, it is accepting. We'll go ahead and submit this problem. So it is accepted. So what we have here is like, for this we can say the complexity will be around, like for each pop and pushing the element will be requiring log of k, since the size, maximum size, we are checking for k elements only, and we are iterating for n elements overall here. So it will become around O of n plus m log k, where m will be the unique element. Since like, why we are taking m into account, because this, the map will be of size m only, right? Size m, because this will be the size of the map will be equal to the unique elements only. So yeah, this is the problem. This is the basic problem we can say, just using the priority queue and the hash map, and this is how you can solve it. If you love the video, please do like and leave a comment, and don't forget to subscribe. Thank you.